Hi, welcome to today's video. We'll be talking about carbohydrates today. So, what are carbohydrates? Carbohydrates are naturally occurring organic compounds that contains carbon, hydrogen, and oxygen. Most organic compounds contain carbon, hydrogen, and oxygen, especially those that can be classified as food. But one special feature of carbohydrate is that the ratio of hydrogen to oxygen is 2 to 1, as in water. For every oxygen, there are 2 hydrogen atoms. So the general formula of carbohydrate can be written this way or this way: CX H2Y OY. It means the amount of hydrogen atoms is usually twice that of oxygen atoms. If you count the carbon and hydrogen and oxygen atoms in this carbohydrate, you will see that they conform to this rule, and in every carbohydrate for that matter. So in carbohydrate, the ratio of hydrogen to oxygen rather is 2:1. Sources of carbohydrate: there are so many carbohydrate food and sources around us. Grains, wheat, examples are wheat, rice, oats, corn, etc. We also have fruits. The sugars in fruits are carbohydrates. So the starch in wheat, in rice, in corn are carbohydrates. Vegetables, potatoes, for example, potatoes, carrots, peas. So the starch in potatoes is a carbohydrate. Sugar in carrots are carbohydrates, and so on and so forth. We also have legumes, beans, and lentils have a measure of carbohydrates in them. Dairy products like milk and yogurt also contain certain degree of carbohydrate. This is very carbohydrate is one of the staple food we eat, that's been eaten around the world. So if you can name other food that is local to your region that contains carbohydrate, it would add to this content. Okay, carbohydrate can be classified into the following. We have monosaccharides. Monosaccharides are also called simple sugars. Examples of monosaccharides are fructose, glucose, and galactose. They are the simplest form of carbohydrates that you come across. We have disaccharides, and disaccharides are made up of 2 simple sugars. From the word di, it means they're made up of 2 simple sugars, and then we'll still talk more about them later. When 2 simple sugars are combined, react together, they form a disaccharide. Most times there is the removal of 1 water molecule for every disaccharide formed. And then oligosaccharides contains from 3 simple sugars to about 10 simple sugars. Examples are raffinose, contains glucose, galactose, and fructose. 3 simple sugars react to form raffinose, and then it's called a trisaccharide. It contains 3 sugar molecules, 3 simple sugar molecules. And then we have the stachyose. Stachyose is a tetra saccharide. It contains 4 simple sugars, 2 galactose molecules, 1 glucose molecule, and then 1 fructose molecule form stachyose. They are generally called oligosaccharides. And then when they contain more than 10 carbon atoms per molecule, they are called polysaccharides. Starch, glycogen, cellulose are polysaccharides. Okay, glucose usually referred to as grape sugar or dextrose, and it cannot be gotten from honey as well and certain sap of plants. The major product during photosynthesis is glucose in green plants. In a laboratory, glucose can be prepared by the acid hydrolysis of starch. Basically, the starch is heated in hydrochloric acid or tetraoxosulfate 6 acid, and then in the process, glucose is formed. Most starch are usually made up of glucose molecules. So, for example, in this equation, starch molecules react with water to form glucose molecule. That's what the acid does. The acid really does not take part in the chemical reaction. What it does is that it adds water molecule to the starch to form glucose molecule. Okay. Physical properties of glucose. It is white and crystalline in nature. It is soluble in water, and then it has its sweet taste. Chemical properties. When concentrated acid is added to glucose, it chars to form carbon. As you can see in this equation, concentrated sulfuric acid would convert glucose to carbon. This is also called a dehydration reaction. And then also, glucose is a strong reducing agent because of the CHO group. The polarity of the oxygen atom makes hydrogen to the hydrogen end of this functional group to be polar as well. That in turn leads to the ease with which glucose molecule can donate hydrogen. And you know, in terms of hydrogen, a substance that donates hydrogen in this way is called a reducing agent. It brings about reduction. So when you add oxidizing agent to glucose, there's usually a chemical reaction. It is readily fermented to ethanol and carbon dioxide by the enzyme Z-mase. It is the reason why palm wine would be converted to an alcoholic beverage after a couple of days. So Phelin solution is more or less like an oxidizing agent. It will react with glucose to form a brick red precipitate. So that's how we test for glucose. So when glucose is added to Phelin solution, a brick red precipitate is formed. Okay, these are the structures of this is the structure of glucose and the structure of fructose. As you can see, the carbon carrying the oxygen also carries hydrogen in glucose molecule. Because of the fact that oxygen is very electronegative, it tends to draw the electrons in this bond to itself, and as such, making the hydrogen end of the molecule polar, which in turn can be easily donated and making glucose reducing in nature. Okay, you can test yourself with this task to see if you are following what we are doing so far. What are carbohydrates? Can you give examples? Can you differentiate between proteins and carbohydrates in terms of functional group And then the basic unit. From what we've done so far, the basic unit of carbohydrates are simple sugars. When they are just simple sugars, they are called monosaccharides. When they are made up of two simple sugars, they are called disaccharides. When they are made up of three or more simple sugars, they are called oligosaccharides. And then more than 10 simple sugars, they are called polysaccharides. So can you differentiate between glucose and fructose? So if you can, it means you are following. Okay, let's talk about disaccharides. Disaccharides are simple sugars disaccharides are sugars containing two molecules of monosaccharides. They are equally simple sugars anyway. Their general formula is this C12H22O11. This is obtained by the fact that two simple sugars combine together with the removal of one water molecule to form the disaccharide molecule. Examples of disaccharides are sucrose, majorly gotten from sugarcane; lactose, majorly gotten from milk; maltose, majorly gotten from malt. So in glucose, sucrose is made up of glucose and fructose. Lactose is made up of glucose and galactose, and then maltose is made up of two glucose molecules. So basically, two glucose molecules combine together with the removal of one water molecule to form maltose. A glucose molecule and a galactose molecule react together with the removal of one water molecule to form lactose, and then a glucose molecule and a fructose molecule react together with the removal of one water molecule to form sucrose. So those are disaccharides and the monosaccharides from which they are formed. So sucrose is a common sugar that is used to sweeten foods at home. It is naturally occurring. It is found in pineapple. It is found in sugarcane, and then certain sap of plants. So, but how can it be prepared industrially? It can be prepared by extracting the juice of sugarcane, concentrating the juice by evaporating it so that some of the water molecules in it will dry up, not allowing it to dry totally anyway, because sugar can be destroyed by heat, and then keeping the mixture called syrup to dry. In that process, crystals of the sugar will be formed, and then when they are filtered, in cases where water molecules are still left, you get sugar crystals. Sometimes in the industry, the sugar crystals that are formed because of impurities sometimes may be brownish. They are sometimes subjected to a bleaching process to whiten them. But if crystallization is done properly, good white crystals can also be obtained. So it is a white crystalline solid. It dissolves readily in water, and then it has a sweet taste. What are the chemical properties of sucrose? Just like glucose, they can be dehydrated by concentrated sulfuric acid to form carbon or charcoal and water. It undergoes hydrolysis to form glucose and fructose when heated with concentrated sulfuric acid or hydrochloric acid. In the presence of yeast, which contains the invertase enzyme, it undergoes inversion to form glucose and fructose molecules. It is a non-reducing sugar because of the absence of the carbon oxygen bond as a carbonic functional group. Okay, it's also used for sweetening foods and beverages. It's used for ethanol production by fermentation process. Those are the major uses of sucrose. Test your knowledge, and then you can use a comment section or the Google Classroom platform. Thank you.